Alright, okay, let's look at this question. So this is a very good question to study that revise all the formula that you should know, right? The events A and B are such that probability of event A is 103 and probability of event B is 205, and the probability of B given A, complement of A, is equals to 11 over 20. So find the probability of the following, right? Pause the video, all right? Copy down the question, try the question. I really want my student to try the question, right? Before looking at my solution. All right. Okay, now I will start discuss. So, they are giving you that the probability of A, right? The probability of A is 1 over 3. And the probability of B is 2 over 5. And the probability of B given A, the bar here, right? If you see carefully, you see that there is a bar A, right? This is the same meaning, equivalent form of complement of A, right? So I can just rewrite this to be A prime, which is the same as 11 over 20. 11 over 20. Alright, okay. So now the first question, this is all the information given, right? So this is already know that probability of A, probability B, and this we still can be modified, right? So we have to understand what is this, right? What is the formula involved? So doesn't matter. So if we just look at it, what is the condition? What is the question asking for? Right. The first question is asking for the events of A intersect with event of B. So definitely we have to use that information here for now. All right. Okay. So you should try first. Right. You should try first. So from here we know that probability. We have to understand the formula. Probability of B given probability of B given A prime, right, is actually the conditional probability, where it's defined to be the probability of B intersect the probability of event complement of A, right? There's a formula for conditional probability, right? So divide by what is given, right? The probability that what is given. So probability of A prime, right? So you have, at first you must understand the formula of conditional probability, right? Okay, later on, then you have to understand this formula also. You have to know what is this formula. Okay, before you do this video, it's better for you to refer to the video that I talk about all the formula for probability, right? All the formula that I talk for the probability until the conditional probability, right? The derivation before you're looking, so that you know that which formula am I using. So now for this case is B intersect with A prime. So the formula I'm using now is probability of B minus probability of A intersect with B, right? We want B, but we don't want the B that share with A, right? So A prime. So of course, complement of A means it's 1 minus probability of A. So you must understand the process here. So later on, then we look at what is the information given, right? We have enough information here, right? Okay, so now you know that this B given A prime is to be 11 over 20. So now this has become a very good reference for you. So probability of B. So you know that 11 over 20, right, is equals to probability of B. Probability of B is given to be 2 over 5. Just put inside 2 over 5 minus with probability of A intersect B. This is what we want. We want to calculate this, right? So divided by 1 minus PA. PA is 1 over 3, right? 1 over 3. With all here, you can already find the value of probability of PA intersect with B. So of course here you have 11 over 20, 1 minus with 1 over 3. You're getting 2 over 3, right? So 2 over 3, this whole thing is 2 over 3. You bring over there, it become multiply with 2 over 3, right? Which is equals to 2 over 5 minus with probability of A intersect with B. Definitely this one can be simplified. 10, right? 10, so you have 11 over 30, which is equals to 2 over 5 minus with probability of A intersect B. Hope you see the process, how I'm doing. The most important thing is you should understand this, how I apply the formula. So it means that the probability of A intersect B, right? Probability of A intersect B, you move over that side, then you take 205 minus with 11 over 30. Then you will get the required probability. Alright, let's calculate. Alright, okay, from which giving us the value of 1 over 30. So means that the answer for probability of A intersect B is 1 over 30, right? 1 over 30. So this is all the working that you should know. So let's look at the next question. Alright, okay, let's continue with part B. Probability of A union B, right? As you also have to understand the formula, right? You have to know the formula for A union B. At first, is this case mutually exclusive? Okay, I can actually know how to answer this question, right? State whether event A and B. Is this mutually exclusive? This one later, right? But I know the result already. Because why? The probability of A intersect B is 1 over 30, right? It's 1 over 30. Means that it's not 0, right? It's not 0. This probability is not 0. Means that events A and B are not mutually exclusive. Alright, so if these events are not mutually exclusive, the formula for A union B, right? So it have to be complete, which is probability of A plus with probability of B. You have to be very familiar with this formula, right? Have to be very familiar because you have learned this quite many times during your secondary school. So probability of A union B is probability of A plus probability of B minus with probability of A intersect with B. So now I want to know the answer for A union B. Very simple. I just put all the value, right? I have 1 over 3 plus with 2 over 5 minus with the intersection 1 over 30. Then definitely I will get my answer. Alright, let's calculate. Which we're giving the answer of 7 over 10. Alright, 7 over 10. So means that I have know the answer for probability of A union B, right? With that working, right, that you need to show, right, is to be 7 over 10, right? Okay, let's continue, right? Without wasting time, let's continue doing question C. Probability of complement of A, event A, given that B occur first, right? Given B. Just now is B given A prime. Now is A prime given B. They have different, right? Now this is two different things. So how to calculate this? Alright, let's see. Alright, okay, let's continue finding this, right? So of course, definitely you need to know the formula of conditional probability, right? So I go slowly. So A prime given B, right? So given, so the formula applied here will be probability of A, complements of A intersect with event B, divide by the probability of B, which is given, right? Probability of B. So very simple, and you also must know this formula, right? It's A prime intersect with B, which is the same as probability of B minus with probability of A intersect with B, right? If this was a B prime, if this is B prime, so this without the prime, so we know that it's PA minus with PA intersect B, right? So divide by the probability of B. So apply the formula, take the value 2 over 5 minus with A intersect B, 1 over 30 overall, divide by the probability of B. 2 over 5. Alright, let's calculate. Alright, which we're giving you the value of 11 over 12. Right? 11 over 12. Sorry, 11 over with, yes, 12. So this will be the answer for part C, right? 11 over 12. Alright, let's look at part D. This one is probability of A given B. Alright, let's calculate probability of A given B. A given B. So, probability of A given B is defined to be probability of A, B intersect with B divided by the probability of B, right? What is given? B. So, this one very easy, right? Probability of A intersect B is 1 over 30 divided by probability of B, which is 2 over 5. So which will give you 1 over 30 multiplied with 5 over 2. So you will get 5, 6, 1 over 12. Right? Means that the probability of A given B is 1 over 12. Right? Hope you understand. Alright, okay, I have modified the question by adding one more item. The probability of complement of A, events A, given complements of event B. So for this, how we're going to do, right? So we have E, they're asking to finding, okay, for E, they're asking us to finding that the complement of A given that complement of B. So, as to finding this, very simple, you have still apply the same formula for conditional probability, right? Given B prime is actually the same as the intersection of complement of event A intersect with the complement of event B, right? Divided by the probability of B prime. So I just want to revise this formula so that when you watch this video, you know how to apply the formula. So as this you have, I have discussed before during the derivation, we can using the De Morgan rule, right? De Morgan rule, where we can rewrite this to be the A union B complement of A union B, right? Because this by De Morgan rule, you can rewrite this whole thing to become A union B complement of A union B. So divided by B complement of B. So as you understand, the concept of complement means that, for example, A union B, the complement of A union B means that it's 1 minus with probability of A union B, right? So as you know, the probability of A union B plus with its complement, definitely you're getting 1, right? Same thing also, you have the 1 minus with probability of event B. So of course, definitely you can get all the information there, right? A union B is 7 over 10, right? 7 over 10. And probability of B will be 2 over 5. And you calculate and you will getting your answer. You have to jot down how you're going to apply the formula. Right, which we're giving the answer of 1 over 2. Right, the answer of 1 over 2. So it means that for this, the answer is 1 over 2. Right, okay, let's look at the final part of this question. State whether the event A and B are independent or mutually exclusive. Okay, you can try to look at the video where I talk about event A, the concept of independent and mutually exclusive. Alright, how to determine whether the events A and B are independent? So definitely you have to understand the concept of independent, right? So the condition for independent, for events A and B, for events A and B to be independent, the condition means that the condition is independent. So there is two way of proving it, verify it. First is you're able to show that the probability of A given B is the probability of A. And also the probability of B given A will be the probability of B. If you can show that either one of these is true, means that this will be definitely independent, right? So means if you can show both is true, if you show both is better, right? So it's true, then definitely it's independent, right? And secondly, we can use the product rule, multiplication rule of probability. Now this is only happen when the multiplication rule is only valid when the event A and B are independent. So which is probability of A multiplied with probability of B. So either the first or the second will be okay. Right, I show you the first one, right? The first one. So very easy because you have all the result here, right? Because you have known that probability of A given B. Probability of A given B, you have calculated to be 1 over 12, right? You have calculated to be 1 over 12. And you look at this, probability of A. Probability of A is 1 over 3. You already fail, right? The test is already failed. Means that they already not follow the condition. Because in order for event A and B to be independent, A given B must be equal to probability of A. You see, these two values is not equal. So means we have with this we already enough show that events A and B are not independent, right? Not independent. Or we can replace this whole thing by the word dependent, right? Means event A and B are dependent. Oh, the second way of doing this would be very simple. The probability of A intersect B, right? A intersect B. So, okay, we have the value of A intersect B, which is 1 over 30. Okay, then we take the probability of A multiplied with probability of B. We see whether the value is the same or not, right? If event A and B are independent, these two will be the same, right? So, okay, let's take probability of A multiplied with probability of B, 2 over 5. You're getting 2 over 15, right? 2 over 15. It's not the same, right? It's not the same. So it means that the probability of A intersect B is not the same. This is a very important reason here. You have to tell the reason because they are not the same, right? They are not the same as the probability of A multiplied with the probability of B. If they are the same, they are independent, right? Same thing for this. The probability of A given B is not the same as the probability of A. Definitely, event A and B are not independent, right? I hope you understand this concept here. Very important concept. I tell you, this is very important, right? And later on, okay, is it mutually exclusive? I have tell you already. Mutually exclusive means that the event A and B do not have intersection between the two events. But from the calculation just now, A intersect B, there is a probability, right? If this event A and B is mutually exclusive, means that the probability of A intersect B is 0. Is 0. But there is a value here. There is a value means the event A and B, there is an intersection, right? There is an intersection here. So it means that because there is a value, right? So there is an intersection. This shows that event A and B are not mutually exclusive. Not mutually exclusive. And also not independent. So you have to explain, right? Alright, that's all for this video. Hope you understand.